Method of sections, here we are. Let's go over this first example. This one we've got, looks like a vertical truss, right? But notice it still has all these triangles. And we've got some applied loads here. There's 4 of them. We've got a pin and then a rocker. What we want to do is we want to find the forces in the members BE, EF, and CB. That's what we want to do. So let's figure out where those are. Here is BE. EF is right here, and then CB is right here. All right, we're going to use method of sections because we don't care about all of the forces in these other members, so we don't need to do method of joints. Now what we need to do, remember, is we need to section our truss so that we only cut through, at most, 3 unknown forces. All right. Now, conveniently, I only want 3 forces. So where do we think the best place would be to cut through this? Hopefully, you thought of right there, because that's where we want to do it. All right, so let's look at that. Now, you have to figure out which half you want to look at. Do we want to use this top one, or do we want to use this bottom one? So now think about that for a second, and then look what all is in the truss. Now, looking at that, we have this pin and this rocker here. So if we use this bottom one, we have to find this force, and that force, just due to the supports. All right, so we would have to do that first. We'd have to draw the outline of the truss and then find these 3 forces. Okay. Now, if we use the one at the top, this top section, notice there are no external supports. So which section makes more sense to use? This one up here. It's less work. If you use this one, you got to do the 2 steps. You'd have to analyze the whole truss, get these 3 forces, and then you could go to the bottom section. We don't want to do all that though. I'll let you do that. It's practice. Okay. So now let's draw out this top half of our truss. Right, so say it looks like this. Now first let's label all of the external forces. We've got the 10 kilonewtons here, 5 kilonewtons, and then 5 kilonewtons there. All right, this is 4 and this is 4. And now let's look at the forces, or the members we cut through. So we cut through these members right here. Now remember, we want to draw the forces going out of the section. That's always going to be easier, I promise you. So just draw them going out. This one here is CB, this one is BE, and this one is EF. And this angle right here is 45 degrees. Alright, so that's going to be our diagram. Now remember, if this whole truss is in equilibrium, this one little section of the truss has to be in equilibrium also. So we're just going to apply our equilibrium equations. And then we can solve for those 3 unknowns. Let's start with our x equation. We've got 5, 10, both in the positive direction, and then we have this negative x component for this BE force. So let's have 5 plus 10 minus BE cosine 45 equals 0. Now conveniently, BE is our only unknown, so let's solve. BE is going to be positive 21.21 kilonewtons. It's positive, that means it's in tension. Right. Now we've got 2 more to do. We've got this one, we need these 2. Let's go ahead and use the y components now. For y, we have negative 5, negative CB, negative EF. Like that. And do we need anything else? What about this one? We got this one too, right? It has a y component. So this one we're going to have negative BE, And then that's going to be sine 45. That equals 0. Now we already know this value. It's positive 21.21. So you can plug that value in. We still have two unknowns here. All right. So we can't do anything with this. Let's go to the moment equation. We could have gone to the moment equation first. I just skipped over it. I'm going to pick point E for mine, for my point for the moment. And I picked that one because we have 1, 2, 3, 4 things going through it. All right, so that's a good point to pick to get rid of some forces. So now with E as our reference point, we only basically need to find two moments. We have a moment due to this and then this. That's it. Let's start with a 5 kilonewton force. That one is pointing to the right. So if we're looking at this point, that's going to be a clockwise rotation, which is negative. So we have negative 5 times 4, because this is our perpendicular distance. And then the only other force that has a moment about point E is CB. Now this one is downward, so that's going to be counterclockwise rotation, which is positive. The distance is 4. So we're going to have plus CB times 4. That equals 0. Now this equation is really easy to solve, right? So the 4's here cancel out. So CB is going to equal 5 kilonewtons. It's positive. That's tension. So CB is a member in tension. Now that we have this, we can finish this one up. So now let's plug that into there. And then we can solve for EF. EF, you're going to get negative 25 kilonewtons. So that's 25 kilonewtons in compression. All right, so that's how you do method of sections. A lot quicker, I think. Not nearly as tedious. But the only issue is you don't get all of the forces in all of the members. You can only get 3 at a time. All right, if you wanted to get these other ones, like if you wanted these 3, you'd have to section it again. You'd have to do multiple sections to get all of the forces. But if you only need a few, this is the method we want. Okay guys, hopefully that one made sense. I will see y'all in the next video for the next example.